Hello guys, in this video I'll try to explain you the solution for this problem, which is product of array except self. So first let me tell you what the problem is. So the problem want us to find the product of all element except the current element. Okay, so by current element I mean the result would be an array. In array we will take each element. Let's say first we took 6, so we want to find the product of all element except 6, so which would be 1 into 2 into 4, so 8. Now let's take 4, so it would be 1 into 2 into 6, 12. Let's take 2, then 1 into 4 into 6, 24. Let's take 1, which is 2 into 4 into 6, 48. So we'll ignore the element for which we are calculating the product. Okay, so now once you understand the problem, let's move to the solution. Okay, so the first intuitive solution you will think of would be this. So let's say this is our array 1 2 4 6 7, and we want to find for this position the product we want to find for this position. So now this is our current element, so we have to ignore this. So we have to find the product of all the elements to its left and all the elements to its right. So on the left there are two elements 1 and 2, so their product would be 2. On the right there are two elements 6 and 7, their product would be 42. Combined product would be 84. So this would be the answer for the result. So like at this position 84 would be there. Okay, and there are two position left. So similarly we have to find the product for each element one by one. So if you watch carefully in this solution, the time complexity is n square. How? Because first we will take a left pointer and move it till here, and then we'll take a right pointer and move it till here, like after 4 and before 4. So there are 2 pointers we have to move, so we will need a while loop, and then this same thing we need to do it for each element. So there are n elements, so n times we have to run these 2 pointers. So that's why the time complexity is as n square. Okay, so n times we will for this example, let's say n by 2 times we will move 2 pointers, left pointer and right pointer. So the combined time complexity is n square. But we can do it even, like we can find even more optimized solution. So let's take an example of this array. So 1 2 4 6 7, same array as before. Now let's see, we are finding for seventh for this position 7. Okay, so on the right there is nothing, so we will take 1. So same way, like on the left side of the 1 there is nothing, we will take 1. Like let's assume there is 1 there. Okay, so we'll do this. Now to find out the left product for 7, we will multiply all the elements in this array except the last element. So it would be 1 into 4 into 6, it would be 48. So this is the left product of 7. And if we do 1 into 2 into 4, we'll get a left product for 6. If we do 1 into 2, we'll get a left product of 4. And if we do 1 into 1, we'll get a left product of 2. Why 1 into 1? Because there's only one element and this element. So if I ignore this also, because that's outside, so it would be 1, which is 1 only. And for 1, the left element is this one, so we get 1 for the 1. Okay, similarly we can find the right product of 1, the first element. So it would be 2 into 4 into 6 into 7, that would be 36. This is the right product of 1. We can find 7 into 6 into 4, this is the right product of 2, which is 168. And 7 into 6 is the right product of 4, which is 42. And 1 into 7, because this 1, so 1 into 7 is 7, right product of 6. And 7, there is nothing on right, so we will just write 1. So right product of 7 is 1. So if you look closely at this pattern, while calculating the left product for 7, I actually calculated left product for all the elements. Because if you see, 7 has this 1 into 2 into 4, which we need for the left product of 6, and 6 has 1 into 2, which we need for the left product of 4, and this 1 into 2 has 1, which is the left product of 2, and 1 into 1 has 1, which is the left product of 1. Similarly, if you see this array, so we are finding right product of 1, which is 7 into 6 into 4 into 2. So if I see, then if I see this, then 7 into 6 into 4 is a right product of 2, and this contains 7 into 6, which is a right product of 4, 42. And if I look closely, it has 7 into 1, okay, which is the right product of 6, 7, and the right product of 7 is 1, because nothing is here, so 1, so 1, okay, and left product of 1 is 1, because nothing is there, so we'll keep it 1. So that's how we got a left product array and right product array. Like if I store all the result when I, so I'll start from here, and move till here. I'll just add one digit to the product, like 1, then 7, then 1 into 7, then into 6, into 4, into 2. So at each step I'll store the result in an array. So 1, then 7, then 42, like 1 into 7, 7, then 7 into 6, 42, then 42 into 4, 68, and 168 into 2, 136. So that's how I'm constructing this both array, left and right. So once I have the left product array and right product array, I can just simply combine them respectively. So this was my left product array, this was my right product array. Now I'm just combining it, because we want to multiply left product and right product to get the final result. So that's how I am getting the final result, by I'm just combining these two array into a multiplication. So that is the solution, and it has the time complexity of n, because we multiplied each element one by one, which is kind of, we ran pointer from first to last, so which is of time complexity n. And after this loop we ran this loop, which is also of n, so n, and then we are multiplying each digit, so another loop, so it would be n. So it's basically n plus n plus n, which is 3n, which is equal to n. So n would be the time complexity for this solution. Now there is one more thing you will think about, is this. So if we want to just ignore this, let's say this number from the whole product, why can't I just divide by this? So let's say this is the whole product for this array is 48, and I want to ignore 2, because second position is 2, uh, like 2 is the value for the second position. Why can't I just divide 2 by 48, and it is just disappeared from the product, and we can get the answer, which is 48, 24, 12, 8. If you see the answer, it's matching 48, 24, 12, and 8. Yeah, you will be right when you think this, and it has time complexity of n, because there is only one loop we'll run that divide each element by its original value. Then what is the problem? The problem is, if we get a 0, then the whole product will become 0, and dividing, no matter by which you divide, it would be 0, and this case is even not defined, so this you have to handle. Plus if we get negative values, then negative divided by negative or negative divided by positive, it changes the sign as well. So these things comes when you think about this solution. So this solution will not work. This is the best solution we have. So let me show you the code for this solution. uh, okay, so this is the code for this solution. So if you look closely, we first defined everything, which is our left product, right product, result array, these three arrays. So we'll loop through these three array, which is n plus n plus n. So this is our main array. This is our product variable, just temporary, just a buffer variable we have created, and this is the length of num. So now we'll loop through the first array, find the product one by one, and then add it to its respective place. This case I added to handle the this case. You remember this case? For the one, the left product would what it would be, I just can't multiply it with the left because there is nothing there, so I'll just put answer 1 if we have the last first element or the last element. So for those cases I added this condition, this and this. Okay, apart from that, yeah, so here we are doing product, here we are doing product. Just remember we are iterating this array backward because we want to add the product. So let's say where I was, yeah, so the right product of 1 is 366. Okay, so but we want this at the first place. Okay, but we are calculating from here 7 into 6 into 4 into 2, we are calculating it from backward, so that's why we are creating this array from the back, so that the maximum result will come into the first. Okay, what I'm saying is, so I'm constructing this array from here, 1 into 7 into something into something into something, I'm increasing in this direction, so I'm building the array from the back, and this array I'm building from the front. If you see 1 1 2 8, it's increasing in this direction. So because we want to multiply this array like this, 336 into 1, uh, because the maximum value for this is right, this right product is 336, so 1 has a right product of 336, which I want to multiply with one's left product, which is 1, which is this. So I want to multiply this minimum value with the maximum value, so that's why I'm constructing this array backward, this in from the front. Okay, so now that's out of the way. So yeah, we got the left product, right product, we multiplied the result, like we multiplied the both array respectively, and we got the result. So yeah, if you see, so yeah, that was the solution for this problem. I hope you like this solution explanation, and I'll see you in the next video. See you, bye bye.